Imagine we are designing the suspension of a new car. We know how we want the suspension to behave, but don't know which shock absorber we need to achieve this goal. To make an informed decision, we'll simulate the model with different suspensions and compare the results with one another. Also, we often have a reference signal, so we'll check if our results are within a desired tolerance of this target behavior. Our Simulink model uses two spring damper systems to represent the front and rear suspension. Let's simulate this model for different values of the damping coefficients to see how the vertical bounce changes. In other words, how smooth the ride is. After setting our initial suspension parameters, we run the simulation. But wait, where do we see the simulation results? We use the Simulation Data Inspector. The Simulation Data Inspector consists of three areas: a left sidebar, the Inspect and Compare pane, and the Graphical Viewing area with buttons to customize our graph. But this is empty right now. Where is our simulation data? To view the results, we need to log the signals we're interested in. Here we select the vertical bounce rate. Then we turn on signal logging via the drop-down menu. An icon indicates that the signal is now being logged. If we need to select more than one signal, we hold the Shift key and click on all the required signals. After running the simulation Data Inspector icon is highlighted to indicate that there is new data available. When we open the Simulation Data Inspector, our logged signal is listed under Run 1 with the model's name in the Inspect pane. To help us keep track of what's changed in each simulation, let's rename results accordingly. In this case, for example, we add the damping coefficients to distinguish future simulation runs. Now we select the signal to view the simulation data. As we run a second simulation to test a different shock absorber, the most recent simulation appears in the active work area and the previous one moves to the archive section below. Proceed with the same workflow of renaming the simulation run and plotting the signals we are interested in. In this case, we inspect the vertical bounce rate of both simulations. To differentiate between the two signals, we either click on the legend to show one of the signals in bold, or we quickly change the color of one signal. Now, to make a design decision, we either compare the behavior of the model under different settings of a component like we just did, or we compare the results to a target behavior, like a reference signal, that we need to come close to. In this example, we've already loaded a reference signal into the MATLAB workspace. How do we get it into the Simulation Data Inspector? In the left sidebar, we go to Import and select the variable in MATLAB to import it. The reference signal is imported as Run 3. Let's see how close we are to the target. Is this close enough? Usually there's a tolerance we need to meet. How can we tell if our result is within a specified tolerance? We use the Compare pane. Here, we define that the baseline is our imported reference signal, and we'll compare it to the signal from the first simulation run. There are several options when defining tolerances. Here, we'll choose Absolute Tolerance. When we compare signals, we see a summary of the comparison on the left and two plots on the right. The summary tells us that the signal is not within the specified tolerance. Let's have a look at where that happened. The first plot shows the two signals with the added tolerance band in green. The second plot illustrates the difference between both signals and where the signal leaves the tolerance band. So, our first suspension model does not meet the design goal. Let's change the Compare To signal to the signal from our second simulation run. Great! With this suspension, we stayed within the tolerance and found a configuration that ensures a smooth ride. Now it's your turn. Check out the Getting Started in the left sidebar to recap what we did and see even more possibilities.